Hello, my name's Tom Zessier. I'm an instructor here at APUS, and I'm going to give you a quick overview of ELEN427 Radar Systems Theory. So in ELEN427, it's a pretty thorough coverage of radar systems. Talk about RF signal transmission, propagation through the air and space and reception. We get into block diagrams of the system, components like transmitters, receivers, antennas. Go over the radar range equation. It's a fundamental equation that describes a radar, kind of the starting point of any type of radar design. Antennas and the beam patterns that they produce, radar cross section, losses, signal to noise ratio, probabilities of detection, and how the radar processes a signal when it detects target. And we'll cover the different types of radars. There's many different types of radars based on the type of function that they perform. Okay, so course outcomes, I'm not gonna read all those off again. Pretty much covers the course description that I just talked about. I will point out a couple of things. The course objective 3, explain the concepts of moving target indicator and pulse Doppler. So those are specific functions that a radar can perform, and those are pretty important in certain types of applications. So I just wanted to point that out in particular. So the relevance to the field, radar's it takes in a bunch of different areas in electrical engineering and combines it into making the radar system. So you need to understand communication theory, electromagnetics, signals and systems, and probability. And radar has many applications. You may know, you may be familiar with some of these. Like if you have an automobile that has a system that warns you when you're backing up, getting close to something, a radar, that's a radar that does that. Many applications in aviation, weather. There's, most aircraft have a weather radar, collision avoidance radar to see if other aircraft are out there in its path. Air traffic control uses radar to detect and track their aircraft. Other applications in the space, military, law enforcement, everybody's probably familiar with that. I don't know if you've got a ticket, you're very familiar with it. Police use radar to measure how fast you're going. If you haven't gotten a ticket, you probably still know about it. Like I said, you use this class in analyzing existing radars, or designing a new radar system. Applications such as military air surveillance, civil and military air traffic control, fire control for surface-to-air missiles. Airborne radars have multiple, they perform many functions, have many different modes, some probably up to like 50 different modes. Guidance for cruise missiles, like I mentioned, vehicle warning systems, navigation on ships and boats. An interesting, kind of a different thing, radars that you may not think of as ground mapping and imaging from air and space. Okay, so what you need to know, like I mentioned, ELEN420 communication systems is prerequisite. So radar is a system that takes in very many different fields to form the system and do all the functions that the system performs. So you also need a solid understanding of magnetic field theory, signals and systems, and mathematical probabilities. Because, in a nutshell, radar sends out a signal, bounces the energy off the target, collects up the energy, processes the signal, tells you if different types of information depending on the function of the radar about the target and about what you detected. So it takes in a lot of different areas. Where you will go, there's no follow-on course or any course that you would need this class for. So hopefully, you graduate and get a job doing radar stuff if that's what you want to do, or you go on to graduate school and do, similar stuff if radar's really what you want to do.